division. And it's exactly what you would think you would do. If they ask you to multiply two functions, you really just multiply them. Division is the only one that requires a little bit of thinking sometimes because you do just divide the two functions, but you have to make sure that you can't divide, like g of x can't go to 0. Since we've been talking so much about domain and range, today when they ask you to do the sum, difference, product, and quotient, they're also going to ask you to say what the domain is. And really, you just take on what the domain of both f of x and g of x are. The only difference is in the quotient. In the quotient, you also might have to take into consideration what would make g of x be undefined in that denominator. So your book says, in each case, the domain consists of all numbers that belong to both the domain of f and the domain of g. And we'll do an example of this where we do the domain of each one of these. And usually the domain is going to be the same for the sum, the difference, and the product. But then the quotient might be a little bit different because you can't have 0 in the denominator. Okay? I don't know. Whatever you want to do. It's your prerogative. That's what song they should play on Friday music. Did they play music class passing period? I totally didn't ever hear any, but I think I was just focusing on math. I think that the login's going to get stormed out tonight. Severe weather, possible hail, they said, starting around 6 o'clock.
It's supposed to rain from 6 to 5. It just rains.
Not a big deal. But thunderstorm, no.
Like, I'm pretty sure.
Hail, will you play if it's hailing but not thundering? That'd be awesome.
Yeah, it'd be loud.
It'd be so loud.
Okay, it'd be awful for the people in the stands. The cheerleaders will be terrible for if it hails. They don't have as many clothes on. Anyway. I'm planning on coming tonight, but I'm going home first, and I'm really going to be disappointed if I drive all the way back and then it's storming. You won't be in attendance? Is that what you said? I know. Parker said it would be cool if it's raining, but I don't know if I want to keep Parker out in the raining night. Wouldn't it be terrible if it was raining on homecoming and all the girls get all dolled up and then it's just pouring down rain when they walk out?
Yeah,
that would be some good pictures for the yearbook. It is. It's a little like crazy little font here. But yes, that's x to the third, and that's the square root of x plus 1. And we're just going to do all 4 and just practice making sure we can add, subtract, multiply, and divide these. But then we're also going to find the domain of each of the operations. They probably would do that. I think they should just let it all like make a run, and that'd be funny. Oh, okay, maybe only I think that's funny. All right, so if I'm going to add these together, I'm just going to add x cubed plus the square root of x plus 1. Can you add those two things together? So you can't add something outside of the square root with something inside of the square root. If you could add them together, obviously I want you to combine like terms. But if you can't add them together, that's it. That's your answer. Right. It's not like A, B, C, or D, circle one. Like we're doing 4 different problems in one problem. Oh, goodness. Sometimes I put questions on a test like this, and people just circle one. It's very disappointing when I grade, when it says, do this, and people just circle B.
That's satisfying.
It's easy to grade, but it's a little disappointing as a teacher. If I'm doing the domain of this, I have to take into consideration the domain of both f of x and g of x. So let's go back and talk about that before we do this. What would be the domain of x cubed? Maybe we wrote it down yesterday. What does x cubed look like again? Like the S shape, where one side's going up forever, one side's going down together. What would the domain is all real numbers. So I'm going to just write up here, domain is negative infinity to infinity. On your homework you do. I don't have it on here, but we're going to practice, because on your homework I believe the directions say to find the domain. I think it just says the domain. We don't really care about the range that much.
That's just for A, right? Is that the whole thing?
We're going to find the domain for all of them. But right now, we haven't even found the domain for A. We've only found the domain for f of x. Okay? So I also have to find the domain of g of x before I can find the domain of what happens when I add them together. The domain of g of x, this is a square root function. Yesterday, when we said the square root of x, we said the domain was from 0 to infinity, because 0 was the smallest number I could plug in there. Is 0 the smallest number I can plug into this one without getting a negative number? Negative 1 would be the smallest number I could plug in there, right? And how do you get that? You just set that equal to 0 and solve it. But I believe this one's domain is going to start at negative 1, and then it's going to be that sideways parabola. So I believe it's going to be from negative 1 to infinity.
That's important that we find those before we find A, B, C, and D.
Well, it is, because the domain of A, B, C, and D is what happens when you put those two domains together, basically. Or if you had both of those functions, you have to take both restrictions into account. Does this one have any restrictions? So it really means nothing, because it could be anything. But this one has restrictions. And so our domain, when we add these two together, you could kind of look at each one separately. This part could be anything, but do you agree this one still can't be anything smaller than negative 1? So the domain is going to be just what that is, which is from negative 1 to infinity. Because although this could be anything, it doesn't matter when we have a square root in our problem. We have to take that into account. That's just for A. But the good news is it's going to repeat itself a lot. Because I was just talking to Justin. When I subtract these, I'm just going to subtract. Not that exciting. I'm just going to take f of x, which is x cubed, and I'm going to subtract g of x, which would be the square root of x plus 1. Can I subtract those two? Can't do anything. I don't have any like terms, so yet again, it's actually kind of a nice problem because I don't have to do anything here.
So basically, these problems are fun.
Well, some of them on your homework you're going to actually be able to combine together, like if there are two polynomials. I picked this one because when you can't do anything, sometimes people think something's wrong, so that's why I picked this one, and because the domain's interesting. If I'm subtracting, am I going to have the same domain? Can this still be anything, but this one can't be anything but negative 1 and bigger? And so my domain is going to be the same. When I multiply these, yeah, this one's not that exciting because I get x cubed times the square root of x plus 1. Can I multiply something outside of square root times something inside of square root? Yeah, I just can write it like this. Like I can't take that and multiply it by x and get x to the 4th if it's not under square root either. Again, obviously, if you could do that, I want you to do it. Is my domain going to be the same?
The domain's always the same.
So we get to quotient. Because in quotient, we have a big deal because now we're moving it to the denominator, right?
Yeah, this one's the same.
But this one is the same because still I can't have anything but negative 1 to infinity. Most of the time, adding, subtracting, multiplying, your domain's going to be the same. So you want to make sure you get it right the first time. But dividing, we're now going to take f of x divided by g of x. That's all right. We're not going to worry about rationalizing that right now. We're just worried about the domain of this. Because we don't care about the range that much. What? No, your homework says to find the domain too. I'm telling you. I'll look right now just to make sure. But I know why. You asked like 4 times. Give the domain of each. Give the domain. We just want the domain. 5 times. You just asked 5 times. I promise. You're only giving the domain. Can this one have the same domain as all these other ones? Does it start at negative 1, including negative 1, and go to infinity? what would happen if I plug -1 into this problem? This would equal 0. I can take the square root of 0. It's okay, but what's the problem in this one? We can't divide by 0. We can't have 0 in the denominator. So what's my domain going to change to say I can't have 0 in the denominator? Domain is never undefined. 0. So Justin says 0. It's just 0? This, I'm guessing? Is that true? Can I plug in anything smaller than 0 in that? Could I plug -1/2 into that problem? So that can't be the right domain if I can plug -1/2 into that problem. Not including -1, right? But all the way up to -1. Oh, so you're saying it just can't equal -1? Can it equal -2? No, I'm just asking. This is how you think about domain. If I just tell you the answer every time, it's not going to be good on the test.
Shame on you for not knowing the answer.
So we don't want to say everything but -1. Do you still agree that we can't go less than -1 because of the square root? So we still have to say -1 is a stopping point. The only difference is I can't plug -1 in here because then I would have -1 over 0. It's my stopping point, but I'm not allowed to use it. So how do I show that in my domain? Parenthesis instead of bracket. That's it.
Why was that discussion so?
Because you were guessing undefined.
Valid guess.
No, domain is never undefined.
You're never
Just so you know. So you write that and it's wronger than wrong.
Wronger isn't even a word.
Wronger than wrong. It's like -2 extra points if you write undefined for domain. Alright. I feel like adding, subtracting, multiplying, dividing isn't that bad. Hopefully. The domain part is the only part that's bad. Also last year we learned this new operation called composition. And lots of people think composition is just multiplication, but it's not. It's taking one function and putting it into another function. And so the way that we show that is that little open circle. That doesn't mean f times g. That means f of g. And last year I told you, if you were in my class, every time you see that little notation, you can just replace it with a set of parentheses, and it kind of tells you exactly what to do. So if you replace that with a set of parentheses, you get this, and it's exactly what that means. It means you're taking g of x, and you're putting it into f of x. So just a little reminder here before we get to the problem. If you have a function like f of x equals 3 plus x, sorry, how about wrote 3 plus 7, that wasn't good. And I say find f of 2, what does that mean to do? It means replace x with 2, and you get 3 plus 2, and you can actually work it out and get a lovely number. It's just another way of finding x, y values. I just made it up. I'm the teacher, I can't. This is the same thing, but the difference is we don't just get to plug a number in to f, we have to plug a whole nother function. So we have to take g of x and replace it for x when we do these problems. So let's do one, and hopefully it'll come back to you here. We might do this both ways here. I should really say find f of g of x. What you don't want to do on these problems is just multiply. So I have f of x equals 3x squared plus 2, and g of x equals 2x. If I want to find f of g of x, that means I'm going to take g of x, and I'm going to plug it into the f of x function and simplify it. You're not going to get a number answer because we don't have a number. We just have two functions. You're going to have x still left in your problem. And if you think of order of operations, you always start with the inside function and work your way out. So hopefully maybe this is vaguely familiar to you, but if I'm going to take g of x and plug it into f of x, could I start by just replacing g of x with what g of x equals, which is just 2x? Like just like up here, when it said find f of 2, right? All I did right here is this is the definition of f of g of x. So I'm taking g of x, substitution says if g of x equals 2x, then I can replace g of x with 2x. That's all I've done so far. Now the second part is actually working this out. If I say find f of 2x, that means go to your f function and replace every x with that entire function. So I'm going to replace the only x that's in this problem with 2x. Everything else stays the same, and I'm going to work that out. So I'm going to get 3 times what g of x is, which is 2x squared plus 2. Taking one function, putting it into another function. And then I just have to work it out. So then we just have to make sure we remember our order of operations here. We're not going to take 3 times 2 first. You have to do your exponents first before you multiply. Right? So I would get 4x squared plus 2. Now I can multiply, and I would get 12x squared plus 2. What if we do the other way? I feel like we need another thing. Well, I want to. I don't know. I just want you to practice it again to show you that the order does matter here. Oh yeah, it says do it both ways on your homework. So now notice that g is the outside function and f is the inside function. That means now we're going to take what f of x equals and we're going to plug that into the g of x function. So on this one, if I start with the inside function, that means g is not going to change right now. And I'm just going to replace with what f of x equals, which is 3x squared plus 2. Find g of 3x squared plus 2. That means in your g of x function, you're replacing x with all of this. So you get 2 times 3x squared plus 2. And then you work it out. Which isn't so bad on this one. I think we get 6x squared plus 4. Questions about that? Vague memories of doing that? When we talk about inverses, this is how you prove that two functions are inverses. When you do their compositions, you get back the identity function. And so when we talk about inverse functions, this is going to come up a lot. You good over there, Logan?
No.
Did you get that?
I'll just let you know.
Okay, just making sure. Because this is not brand new, because you did it last year, they're going to have you do some decomposition of functions. So basically, they're going to give you an answer of f of g of x, and they want you to come up with two functions that would give you that composition. And the idea is, when you have a composition of two functions, you kind of have an outside function and an inside function, right? Like when you think about f of g of x, f is the outside function and g is the inside function. And so you want to kind of look at it and see if you can see like two separate functions in there. So this is already the answer. This is f of g of x. Because they say find f of g such that h of x equals f of g of x. Right? They're telling you that h of x is equal to the composition of f of g.
Okay.
And they want you to come up with what would f of x be and what would g of x be to give you this composition? And there is more than one answer to this. But I want you to start thinking about outside and inside functions here. So when I look at this, I see a square root. Could you kind of say the square root could be like the outside function, and what's under the square root could kind of be like the inside function? And so, just humor me for a minute. If f of x is the outside function, and my outside function is square root, I'm just going to write f of x as the square root of x. Think about our last problem. Both of these had x's in them. We took one and we put in the other one. So you have to have an x in there still. G of x is my inside function. And so if I take what's left on the inside, I get x squared plus 5. What's going to happen if I take this and I plug it into f of x? Am I going to get back that h of x function? So it's not supposed to be a lot of work. It's supposed to be like being able to look at it and seeing two separate equations that you could put together to make one composition. We're not multiplying these two. We're taking this and we're putting it inside there. It wants to make you think. That's what precalculus does. I kind of did that one for you. So let me give you another one and see if you can kind of see the outside-inside function. X plus 7 to the third. So when you look at this, you want to kind of think about, could you tell me what's on the inside and what would be the outside function? And the outside function you have to replace with x because that's what you would plug in when you do your f of g of x. Do you see anything here? Like what kind of looks like on the inside? X plus 7, like that's definitely the inside function, which would be my g of x. So what do you think that the outside function would be so that when I put it together that I would get x plus 7 cubed? Yeah, it's just going to be x cubed. Because if I took this and I plugged it into this, I would get back x plus 7 cubed. So I put a couple of these on your homework. It's not making you do the composition. It's just making you try to separate and see how it's one function inside of another function. Does it kind of make a little sense? People always struggle with this a little bit. Some people see it right away, and some people just really struggle to see it. I got one more thing, and I'm done. An implicit equation. It's a new thing for us. Is when it's two equations put together, and I'm not really going to make you do much with this, except for I want you to get it back into the two equations, like the two separate equations that you could put together to make this one implicit equation. And so the directions on this one say describe the graph of this equation. Notice that it has x's and y's on the same side. That's what makes it implicit. Normally our equations are y equals something. On your homework, the directions just say find the two functions defined implicitly, which means they're going to give you this equation, and we're just going to work backwards to find those two functions. And what we want to do is we want to get it solved for y, and that's how you're going to come up with these two equations. So it's just some good practice, some algebra skills here. So this one's x squared plus 2xy plus y squared equals 4. If I want to get y by itself, what would be a good first step? Kind of not so pretty there, huh? It'd be nice if there was only one y in that problem, right? That would make things a lot easier. But it's not so nice there. What if, do you notice that this looks like a nice little trinomial? This is x squared, this is y squared, nice little number in the middle. You think we could try to factor this? I think we should try. with our brains, that's how. Let's just undo FOIL here. What multiplies together to give me x squared? Normally we have a number at the end, but it's okay there's a letter down here. What could I multiply together to get y squared? Y and y. My middle term is plus 2xy. If I multiply x times y and x times y, could I add them together to get plus 2xy? I think that just factors into x plus y. X plus y. How's that going to help me? Can I just break those up and set each one of them equal to 4? No, you're only allowed to do that if it equals 0. Can you break it up and solve for each one? Since it's the same, could I write it like this? X plus y squared equals 4? Maybe? Why is that going to help me? Yeah, now this is a perfect square equaling a number. I could take the square root of both sides, and I'm going to get x plus y equals plus or minus 2. Can I get y by itself now? I can just subtract x over. Negative x plus or minus 2. It's okay if you leave it like that. I'm going to separate it into two equations. Negative x plus 2 and y equals negative x minus 2. If you graph those two linear equations together, you would get the same thing that if you graph that implicit equation, which is kind of hard for us to graph. So it's kind of just some algebra here. We're not doing a lot with implicit stuff. It's just kind of practicing solving it. Maybe you'll be completing the square, or doing the quadratic formula to solve for y on some of these. We'll look at those tomorrow. I feel like that's going to be the toughest part of your homework. Questions on that? This is on your homework sheet. Just so you know, the directions on your homework. It asks you to find the domain of the adding, subtracting, multiplying, dividing, which we did. It also asks you to find the domain of the composition, and that's a little confusing, not impossible to do, but I don't feel like it's that important, and I feel like it really is hard for a lot of people. So on the part that says find the domain of when you're doing f of g and g of f, you don't have to do that, okay? But on the other part, like the beginning ones, 1, 2, and 5, those are ones that you do need to find the domain on, okay? If it's adding, subtracting, multiplying, dividing, just like we did in the notes, we're going to find the domain of it.